Hello, my dear children. Welcome to the mathematics class. In the previous class, we have discussed different kinds of conic sections, and we have focused the first kind of conic section in the exercise 11.1. That is a circle. That is the first kind of conic section. Okay, my children. I hope you have understood well about the circles, and I hope you have memorized the equation of a circle with the center at h comma k and radius r, and I hope you have learned the problems related to the circles, haven't you, my children? Right. Now come to the concepts of second exercise 11.2. In this exercise, we focus on second kind of conic sections, that is parabola. Okay, my children, are you ready to listen the class? Right. In this exercise, we focus on the second kind of conic sections, that is parabola. Okay, my children, right. So in this slide, we are going to discuss about parabola. What is meant by a parabola? What is the definition of a parabola? Okay, my children, right. See the definition of a parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point. That point should not be on the line in the same plane. Okay, my children, this is the definition of a parabola. Do you remember the definition of a circle, my children? The set of all points in a plane which are at a fixed, which are at a equidistant, which are at equidistant from a fixed point in the plane. Yes or no, my children? Now come to the definition of parabola. Parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point, and that fixed point should not be on the line. Okay, my children, in the same plane. Understood this definition, my children? Right. The fixed line is called the directrix of the parabola, and the fixed point F is called the focus. Okay, my children, focus of the parabola. Here para means for and bola means throwing. That is the shape described when you throw a ball in the air. Okay, my children, this is about, observe this figure, my children. If you throw a ball in the air, the path of the ball in the air looks like a parabola. That is why this curve, the name of the curve is named as a parabola. Here the fixed line, this is the fixed line in the plane, L is the fixed line. This fixed line is called directrix, and the fixed point in the plane is said to be focus. Understood this point, my children? These are the points which are equidistant from the fixed point F and from the fixed line L. That is F P1 is equal to P1 B1, F P2 is equal to P2 B2, F P3 is equal to P3 B3. Then the set of all these points form a parabola. Understood this point, my children? Right. Please remember this point, my children. The fixed point lies on the fixed line. Then the set of the points in the plane, which is equidistant from a fixed point, and the fixed line is the straight line through the fixed point, and the perpendicular to the fixed line, we call this straight line as degenerated case of parabola. Okay, my children, understood this point? If the fixed point lies on the fixed line, that means the focus lies on the fixed line, the directrix, then the set of the points in a plane which are equidistant from the fixed point and the fixed line is the straight line through the fixed point and perpendicular to the fixed line. Yes, my children, understood this point? So we call this straight line as degenerated case of parabola. Then we get a straight line. In this case, this straight line is said to be degenerate case of the parabola. Understood this point, my children? Right. Now, in this slide, let us discuss the parts of the parabola. Okay, my children? Yes. See this point, a line through the focus and perpendicular to the directrix is called the axis of the parabola. The point of intersection of the parabola with the axis is called vertex of the parabola. Please observe the figure 11.13, my dear children. 11.13. This is the figure 11.13. This is the line through the focus. This is the line through the focus and perpendicular to the directrix. Then this line is said to be axis of the parabola. Please remember these definitions, my dear children. Please remember these definitions well. What is meant by directrix of the parabola, what is meant by axis of the parabola, what is meant by focus of a parabola, and what is meant by vertex of a parabola. Okay, my children. So the line through the focus and perpendicular to the directrix, this line is said to be axis of the parabola. Understood this point, my children? What is meant by axis of the parabola? And the point of intersection of parabola with axis, this point is called vertex of the parabola. What is meant by vertex of the parabola? The point of intersection of axis of the parabola and parabola. Okay, my children. Then this point is said to be vertex of the parabola. Understood these points, my children? What is meant by directrix of the parabola, what is meant by axis of the parabola, and what is meant by vertex of the parabola. Okay, my children? Right. In this slide, we are going to discuss the standard equations of a parabola. Okay, my children? Right. The equation of a parabola is simplest if the vertex is at the origin and the axis of symmetry is along the x-axis or y-axis. Okay, my children. Now, four possible such orientations of parabola are shown below in the figure 11.15a to d. Okay, my children. Observe this first figure, my children. Here, in the first figure, if you observe, what is the vertex of the parabola? Origin. The vertex of the parabola is at origin. Yes or no, my children? And what is the axis of symmetry of the parabola? Or simply we can call axis of the parabola. Here, what is the axis of the parabola? Positive x-axis. In this case, we say that the parabola is opened right side. Okay, my children. right opened parabola. Simply we say that this parabola is right opened parabola. Here this parabola extends indefinitely right side. Okay, my children, understood this point? Right. Now come to the second figure, figure B. Observe this parabola, my children. What is the vertex of this parabola? Yes, the vertex of the parabola is at origin. And observe the axis of the parabola or axis of symmetry of this parabola. Yes, negative x-axis. Okay, my children. Right. In this case, we say that the parabola is left opened parabola. Here, this left opened parabola extends indefinitely left side. Understood this point, my children? Right. Now come to the third figure, C. If you observe this parabola, what is the vertex of the parabola? Yes, the vertex of the parabola is at origin. And now come to the second point. What is the axis of the parabola? Or we can say that axis of symmetry of the parabola, positive y-axis. This is the axis of symmetry of the parabola, or simply we call it as axis of the parabola. Here positive y-axis. Positive y-axis is the axis of this parabola or axis of symmetry of this parabola. Understood this point, my children? Here this parabola extends upwards indefinitely. Here this parabola extends upwards indefinitely. Understood this figure C, my children? Right. Now come to the figure D. Now observe this parabola, my children. What is the vertex of this parabola? Yes, the vertex of the parabola is at origin. Okay, my children. Then what is the axis of this parabola, or what is the axis of symmetry of this parabola? Negative y-axis. Yes or no, my children? Right. In this case, we say that the parabola is opened downwards. Here this downside opened parabola. This extends indefinitely downwards. Understood this point, my children? Right. Now let us derive the equation of the parabola in the standard form. Okay, my children, as we have derived the equation of the circle whose center is at ordered pair h comma k and the radius r in the previous exercise 11.1. Do you remember that derivation of the circle, my children? Right. Similarly, here we derive the equation of the parabola in the standard form. Okay, my children? Right. Now, we will derive the equation for the parabola shown above in the figure 11.15a with focus at 100 per a comma 0 and a is greater than 0. A is a positive number and the directrix is equal to x is equal to minus a. Equation of the directrix is x is equal to minus a. We have taken focus of the parabola is at 100 pair a comma 0 and the equation of the parabola is taken as x is equal to minus a. Understood this step, my children? Right. Before deriving the equation of the parabola, observe this figure 11.16. Here focus is at the point ordered pair a comma 0 and the L is a directrix and equation of this directrix is x is equal to minus a. Okay, my children? Right. Let F be the focus and L be the directrix. Okay, my children? We have assumed this point F is focus of the parabola and the line L is directrix of the parabola. Understood this point, my children? Right. Let FM be perpendicular to directrix and bisect FM at the point O. Produce MO to X. Okay, my children. See here, first of all, we have drawn a perpendicular line FM to the line L. Okay, my children, and we have bisected FM, means we have found the midpoint of FM, that is denoted by the point O. Okay, my children. After that, we have produced this line MO to X. Understood this step, my children? Right. By the definition of parabola, the midpoint O is on parabola and is called the vertex of the parabola. Okay, my children. See here O is the midpoint of FM and this point O lies on the parabola. Okay, my children, because FO is equal to OM, equidistant. This point O is equidistant from the focus and from the directrix as well. That is why this point lies on the parabola. Understood this point, my children? And this point is taken as a vertex of the parabola. Okay, my children, because this line is perpendicular to directrix and it is passing through the focus. So automatically this mx is axis of the parabola. Okay, my children. After that, what is meant by vertex of the parabola? Yes, the point of intersection of the parabola and axis of the parabola is taken as vertex of the parabola. That is why this point is O is vertex of the parabola. Understood this point, my children? Right. Take O as origin, OX the x-axis and OY perpendicular to it as y-axis. Okay, my children. Now let us assume that this point O is origin and this OX line is taken as x-axis and OY is perpendicular to this OX and it is taken as y-axis. Okay, my children, understood this point? Understood this step? Right. Let the distance from the directrix to the focus be 2a. Okay, my children, let us assume that the distance of this point O focus F from the directrix is 2a units. From here to here, 2a units. That's what my children, because from here to here a units and from here to here is a units. So total distance is 2a units. Understood this point, my children? The distance of the point F from the directrix is 2a units. Okay, my children? Right. Then the coordinates of the focus are ordered pair a comma 0 and the equation of the directrix is x plus a is equal to 0 as in the figure 11.16. So automatically this coordinates of this point is f a comma 0 and the equation of this directrix is x plus a is equal to 0 or x is equal to minus a. Understood this point, my children? Right. Let P ordered pair x comma y be any point on the parabola such that PF is equal to FB. Okay, my children, where PB is perpendicular to line L. Here we have taken a point P ordered pair x comma y be any point on this parabola. Then PF, the distance between the focus and the point, and is equal to the perpendicular distance of this point from this line PB. PF is equal to PB. It is equidistant. The point P is equidistant from the focus and the directrix. Understood this point, my children? Right. The coordinates of B are ordered pair minus a comma y. Then the coordinates of this point B are ordered pair minus a comma y, because here see this one, here x coordinate is minus a and it is here y units. From here where x axis it is at a distance of y units. That is why the coordinates of this point B is ordered pair minus a comma y. Understood this point, my children? Understood this step? Right. By the definition of distance formula, we have PF is equal to square root of x minus a whole square plus y square, and PB is equal to square root of x plus a whole square. Okay, my children, understood these two values, PF and PB values. Okay, my children, right. Since PF is equal to PB, we have square root of x minus a whole square plus y square is equal to square root of x plus a whole square. We have equated these two quantities because P lies on the parabola. So distance of the point P from the focus is equal to the distance of the point P to the line directrix. That is why we have this equation. Understood this step by children? Right. By squaring on both sides, we get x minus a whole square plus y square is equal to x plus a whole square. Here we have removed square root symbol on both sides. Then we get this step, x minus a whole square plus y square is equal to x plus a whole square. Understood this step, my children? Right. This implies in the LHS we apply a minus b whole square for this term. So x square minus 2ax plus a square plus y square is equal to, here in RHS we use the algebraic identity a plus b whole square. Then we get x square plus 2ax plus a square. Understood this step, my children? Right. This implies y square is equal to 4ax comma a greater than 0, because here on both sides, here x square terms gets cancelled. Yes or no, my children? X square terms gets cancelled. We strike out x square terms on both sides and a square terms on both sides. By simplifying these terms, finally we get here y square is equal to 4ax. Understood this step, my children? Right. Hence, any point on the parabola satisfies y square is equal to 4ax. Let us assume that this result, y square is equal to 4ax, as equation 2. Okay, my children? We got this condition. Okay, my children? Understood this step? Right. Conversely, let P ordered by x comma y satisfy the equation 2. Okay, my children. Then Pf is equal to square root of plus, what is y square here? 4ax. Okay, my children. So let us substitute y square is equal to 4ax. So x minus a whole square plus y square means here 4ax. From the equation 2 we get plus 4ax. Understood this step, my children? In the place of y square we used here 4ax from the result 2, equation 2. Understood this step, my children? Right. That is equal to, what we will get? X square root of x plus a whole square. By simplifying these two terms, finally we get the square root of x plus a whole square. Understood this step, my children? Right. That is equal to PB. Let us consider this result as equation 3. So PF is equal to PB. Understood this step, my children? Right. And so P ordered by x comma y lies on the parabola. Okay, my children? So because this equation satisfies the condition. Okay, my children? Understood this point? Thus, from the equation 2 and the equation 3, we have proved that the equation to the parabola with vertex at the origin and the focus at ordered by a comma 0 and the directrix x is equal to minus a is y square is equal to 4ax. Please remember this equation, my children. This is the standard form of parabola. The equation of the parabola in the standard form. Okay, my children, understood this point? Right. Now let us discuss by observing the equation 2 and 3 we get here a is greater than 0, x can assume any positive value or 0 but no negative value, and the curve extends indefinitely far into the first and the fourth quadrants. The axis of the parabola is positive x-axis. Okay, my children, we observe that this is the observation from the equation 2. Here a greater than 0 we have assumed at the beginning of the derivation. So x takes any positive value or 0 but not negative value. That is why the curve extends indefinitely far into the first and fourth quadrants. The axis of the parabola is positive y-axis. In this case, the axis of the parabola is positive x-axis. Okay, my children, right. Similarly, we can derive the equations of the parabolas in figure 11.15b as y square is equal to minus 4ax, and in the figure 11.15c as x square is equal to 4ay, and figure 11.15d as x square is equal to minus 4ay. These four equations are known as standard equations of the parabolas. Okay, I mentioned y square is equal to 4ax and y square is equal to minus 4ax, x square is equal to 4ay, and x square is equal to minus 4ay. All these four equations are said to be standard equations of the parabola. Okay, my children, understood this point? Right. Note, please remember this point, my children. The standard equations of parabola have focus on one of the coordinate axes, vertex at the origin, and thereby the directrix is parallel to the other coordinate axis. As I mentioned. However, the study of the equations of parabolas with focus at any point and any line as a directrix is beyond the scope here. Here we study only the parabolas in the standard form. We are not taking the vertex of the parabola at any point in the coordinate axis. Please remember this point, my children. Now, focus should be lie on the either on the x-axis or either on y-axis, so that the directrix is parallel to the axis. Origin, vertex of the parabola is taken at origin. Please remember all these points, my children. Okay, my children. Right. From the standard equations of the parabolas, figure 11.15, we have the following observations. By observing the standard equations of the parabola, we observe the following points. Okay, my children, let us discuss these observations here. The first observation, parabola is symmetric with respect to the axis of the parabola. If the equation has a y square term, then the axis of symmetry is along x-axis, and if the equation has an x square term, then the axis of the symmetry is along y-axis. Please remember this point, my children. In the equation of the parabola, if y square term is given, then the axis of symmetry is along x-axis, and if the equation of the parabola has x square term, then the axis of symmetry is along the y-axis. Okay, my children, please remember this point. Next, second point, when the axis of symmetry is along the x-axis, the parabola opens to the first point, right, if the coefficient of x is positive. If the coefficient of x is positive, please remember this point, my children. If the coefficient of x is positive, the parabola opens to right indefinitely. Okay, my children, right. And the parabola opens left if the coefficient of x is negative. If the coefficient of x is negative, the parabola opens left indefinitely. Okay, my children, understood this point? Right. Now come to the third point. When the axis of symmetry is along with the y-axis, the parabola opens. Here are also two cases. Open upwards if the coefficient of y is positive. Okay, my children, if the coefficient of y is positive, the parabola opens upwards indefinitely. Okay, my children. Similarly, the parabola opens downwards indefinitely if the coefficient of y is negative. Okay, my children, understood these points? We have to remember all these observations. We have to remember all these points, which are very useful in finding the equation of a parabola. Okay, my children, right. Now let us discuss another definition, that is latus rectum of a parabola. Latus rectum of a parabola. What is meant by latus rectum of a parabola? The latus rectum of a parabola is a line segment perpendicular to the axis of the parabola through the focus and whose endpoints lie on the parabola. Okay, my children, understood this definition? Please observe the figure 11.17. Here, this is a parabola in the standard position. Means the vertex of the parabola is at the origin and the focus of the parabola lies on the x-axis. Axis of the parabola is x-axis. Okay, my children. Here, this is the line segment which is perpendicular to axis of the parabola and it is passing through focus, and endpoints of this line segment lie on the parabola. Okay, my children, understood this point? What is meant by latus rectum? It is a line segment which is perpendicular to axis of the parabola and it passes through focus of the parabola, and endpoints of the line segment should lie on the parabola. Okay, my children, right. To find the length of the latus rectum of the parabola, y square is equal to 4ax. Observe the figure 11.18. See the figure, my children, here 11.18. This is the figure 11.18. Now we are going to find length of the latus rectum. As we have defined, latus rectum is a line segment, so we can find length of the latus rectum. So here we have taken the parabola y square is equal to 4ax. For this parabola, we are going to find length of the latus rectum. In this parabola here, AB is said to be latus rectum because it is perpendicular to axis of the parabola and it is passing through the focus of the parabola, and endpoints of the latus rectum lie on the parabola. Okay, my children. Now we are going to find length of this line segment AB. Nothing but length of the latus rectum. Understood this point, my children? Right. By the definition of the parabola, AF is equal to AC, but AC is equal to FM, that is equal to 2A. Hence, AF is equal to 2A. And since the parabola is symmetric with respect to x-axis, here see this point, my children, because A lies on the parabola, AF is equal to AC. Sorry, my children, the distance of this point, any point on the parabola is equidistant from the vertex and to the directrix. So AF is equal to AC. But here AC length is 2A. As I mentioned, FM, it is equal to FM. So AC is equal to 2A. So AF is equal to FM is equal to 2A. Yes, I mentioned, but AC is equal because it is a rectangle. So AC is equal to FM, that is equal to 2A. Hence AF is also 2A. Understood this point, my children? And the parabola is symmetric with respect to x-axis. Okay, my children, understood this point? Right. So AF is equal to FB. AF is equal to FB. Yes, I mentioned. So AB is equal to length of the lattice rectum, that is equal to 4A. AF length is 2A. So AF is equal to FB. So length of the lattice rectum is equal to 4A. Understood this point, my children? Right. These are the concepts of the parabola. Okay, my children. To understand these concepts well, let us take some examples. Okay, my children. See this example. Find the coordinates of the focus, axis, the equation of the directrix, and lattice rectum of the parabola y square is equal to 8x. Understood this question, my children? Here equation of the parabola y square is equal to 8x is given. We have to find all these points related to parabola, coordinates of the focus, and what is the axis of the parabola, and what is the equation of the directrix, and what is the length of the lattice rectum of the parabola. Okay, my children, understood this point? Right. Now come to the solution part. The given equation involves y square. So the axis of symmetry is along the x-axis. So number children, if you observe the equation of this parabola, it has a y square term. So the axis of the parabola or axis of symmetry is along the x-axis. Understood this point, my children? So we have found this point, axis of the symmetry of the parabola. Okay, my children? Right. The coefficient of x is positive. So the parabola opens to the right. Comparing with the given equation y square is equal to 4x, we can find a is equal to 2. Understood this point, my children? After that, we have to observe coefficient of x, whether it is positive or negative. By observing this equation, we can find that coefficient of x is a positive. So the parabola opens to the right indefinitely. Yes or no, my children? And we compare this equation with y square is equal to 4x. Then what is the value of 4a here? 4a is equal to 8. From that equation, what will you find? A is equal to 2. We get a is equal to 2. Understood this step, my children? Right. Thus, the focus of the parabola is ordered by a, 0, and the equation of the directrix of the parabola is x is equal to -2. See the figure 11.19, my children. To understand this concept, that has represented this graphically. Okay, my children. Observe this figure 11.16. In this figure, the focus of the parabola is at ordered by 2, 0. The directrix is x is equal to -2. Okay, my children, understood these points? Focus of the parabola is at ordered by 2, 0, and the equation of the directrix is x is equal to -2. So we got here focus of the parabola. We have already found axis of the parabola or axis of symmetry of the parabola is x-axis. We have found equation of the directrix. And the last one, we had to find the length of the lattice rectum. What is the formula length of the lattice rectum? 4a. Do you remember that point, my children? So length of the lattice rectum is equal to 4a. That is equal to 4 into 2. That is equal to 8 units. Understood this step, my children? Length of the lattice rectum is equal to 4a. So 4 into what is the value of a here? 2. So 4 into 2 is equal to 8. Understood this example, my dear children? Right. Now let us take another example. Okay, my dear children. find the equation of the parabola with the focus at ordered pair 2, 0 and directrix x is equal to -2. Understood this question, my children? Here in this question, focus and directrix of the parabola were given. In the previous question, we are given equation of the parabola. From the equation of the parabola, we have found focus, axis of the parabola, directrix, equation of the directrix of the parabola, and the length of the lattice rectum. Yes or no, my children? Now, in this example, we have to find equation of the parabola with the help of focus and directrix of the parabola. Okay, my children, understood this point? Right. To understand this question, let us represent this given data as a figure. Okay, my children, right. Since the focus ordered pair 2, 0 lies on the x-axis, as I mentioned, this point lies on x-axis. The x-axis itself is axis of the parabola, line of symmetry, or axis of the parabola. We can call it as axis of the parabola or line of symmetry. As I mentioned, hence the equation of the parabola is of the form either y square is equal to 4ax or y square is equal to -4ax. Okay, my children, right. Now, what is the equation of the directrix here? X is equal to -2. Here, equation of the directrix is x is equal to -2, and the focus is ordered pair 2, 0. The parabola is to be the form of y square is equal to 4ax with a is equal to 2. Yes or no, my children? Right. Hence, the required equation of the parabola is y square is equal to 4 into ax. Yes or no, my children? What is a here? 2. So 4 into 2 into x. That is equal to 8x. Understood this point, my children? Now let us take another example. Okay, my children? Right. Find the equation of the parabola with vertex at origin 0, 0 and focus at ordered pair 0, 2. Understood this question, my children? What are given here? Vertex of the parabola is given and focus of the parabola is given. Understood this question, my children? In this case, we have to find equation of the parabola. Okay, my children? Right. If you observe these 2 points, vertex and focus, they should lie on the same line. As or no, my children? Here, x coordinates are same. Here, y coordinates are different. As or no, my children? So, here focus lie on y-axis. Yes or no, my children? Right. Now, let us represent this given data geometrically. Here, 0, 2 lies on positive y-axis. Yes or no, my children? So, the axis of the parabola is positive y-axis. Yes or no, my children? Understood this point? And vertex is at origin. Yes or no, my children? So, the required equation of the parabola is nothing but x square is equal to 4ay. Understood this point, my children? Right. Now come to the solution part. Since the vertex is at ordered pair 0, 0 and the focus is at ordered pair 0, 2 which lies on y-axis. The y-axis is the axis of the parabola. Therefore, the equation of the parabola is the form x square is equal to 4ay. Understood this point, my children? Here, the axis of the parabola is a positive y-axis. Then, what is the equation of the parabola? X square is equal to 4ay. In this equation of this parabola, we have to find the value of a. Okay, my children? Right. Thus, we have x square is equal to 4 into 2 into y. This implies x square is equal to 8y, because here 0, a, here 0, a means a is equal to 2. Understood this point, my children? So we substituted a value in this equation. Then we get equation of the required equation of the parabola. Understood this point, my dear children? Right. Now let us take another example. Find the equation of the parabola which is symmetric about y-axis and passes through the point ordered by 2, -3. Understood this question, my children? We have to find the equation of the parabola, and it is given that the axis of symmetry or axis of the parabola is about y-axis, and the parabola is passing through the point 2, -3. Okay, my children, understood this question? Right. Now come to this diagram, my children. Here the axis of the parabola is y-axis, and this parabola is passing through the point ordered by 2, -3. So it lies in the third and fourth quadrant, downwards. It opens downwards. Since the parabola is symmetric about y-axis and its vertex at origin, the equation of the parabola is of the form x square is equal to 4ay or x square is equal to -4ay. Okay, my children, where the sign depends on whether the parabola opens upwards or downwards. Okay, my children, here the sign of this term, either positive or negative, depends upon the parabola whether it opens upwards or downwards. Understood this point, my children? Right. How the parabola opens up, downwards or upwards? Yes, it opens downwards. As I mentioned, 2, -3. This point lies in the fourth quadrant. So the parabola is passing through the point which is in the fourth quadrant. So the parabola downwards, opens downwards indefinitely. Understood this point, my children? Right. But the parabola passes through the point ordered by 2, -3, which lies in the fourth quadrant. It must open downwards. Thus, the equation is of the form x square is equal to -4ay. Yes or no, my children? Understood this point? Right. Since the parabola passes through the point 2, -3, we have 2 square is equal to -4a into -3. This implies a is equal to 1/3. Understood this point, my children? Understood this step? We have substituted this point in the above equation. X square is equal to -4ay. Okay, my children, where x is equal to 2 and y is equal to -3. Then we find the value of a from that equation. Here we got a is equal to 1/3. Understood this step, my children? Right. Therefore, the equation of the parabola is x square is equal to -4 into a means here 1/3 into y. Understood this step, my children? In the above equation we substituted the value of a. Then we get x square is equal to -4 into 1/3 into y. Okay, my children, we rewrite this equation by cross multiplication. We get 3x square is equal to -4y, which is the equation of the parabola. Understood this point, my children? Right.